So in the last lesson, we learned that the square that is on the hypotenuse of the triangle its area is equal to the sum of the other two squares. And the other way of saying that is that the a square plus the b square, or the area of the a square plus the b square, is equal to the area of the c square. And so we'll demonstrate that again here just to get started on this particular set here. And so we have our a squared, its area would be 4. We have our b square, its area would be 25. And we have our c square, 25 plus 4 is 29. And so there is a way we can manipulate this algebraically to figure out what the value of the side length that we don't know is. And so we can obviously tell that if we were to follow the sides of the triangle, this is 1, 2, 3, 4, 5 units, and it matches that left side of the triangle, and that this is 2 units and it matches the base of our triangle. The piece that we still have a question about is we don't know how long this line is, which is the line that matches the hypotenuse of our triangle. And that is our C that we're looking for there. So what's going to happen is we're going to take the relationship that we noticed in the last lesson, the a squared plus b squared equals c squared, and we're going to use it to figure out how long that opposite side of that triangle, or the hypotenuse of that triangle, must be. And so our A was already designated for us. It is a side length of 2. You see it up there as the kind of light purple square. The left side there, we had a side length of 5, which is kind of a darker purple square. And then the C is the side that we don't know. So in your calculator, we're going to solve for x. And so there's a step kind of missing here that I'm going to write in, actually, because I hate it when steps are skipped. We would put in 2 squared plus 5 squared, which would give us 2 squared is 4, plus 5 squared is 25. That would give us 4 plus 25 is 29. Now the next piece that needs to happen is 29 is equal to c squared. And so to undo a square, what needs to happen is we need to take a square root. So we're going to take the square root of both sides. We're just solving this equation. And if you're to do the square root of 29 in a calculator, when I say undo, I shouldn't say undo, I should say the inverse operation. The inverse operation of squaring is to take the square root. So square root of 29 is going to give us 5.38, which would round to be 5.39 if you go to the hundredths, or 5.4 if you only go to the tenths. We're going to be taking that idea and applying it to some triangles here today to find the length of the hypotenuse. And so we're going to just repeatedly use this equation. So a squared plus b squared equals c squared. We just need to identify where is c. Well, there's the right angle looking across. That has to be c. I'll choose to make this a and make this b. So my a would be 3. My b would be 4. And we're looking for c squared. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. Then if we take the square root of both of those, the square root of 25 is an easy one, it's 5. So our hypotenuse on that triangle will have a length of 5. Move these things over here so I get a little bit more room on this triangle. All right, looking at getting a phone call. Okay, apologies for the interruptions with the phone call. So the first thing, with any time we're using the Pythagorean theorem to find a length on a triangle, is to identify our hypotenuse and label it C. So that's going to be our C. I will go ahead and make our side that's 5A and our side that's 12B. And so we'll use the Pythagorean theorem over here on the side. A squared plus b squared equals c squared. The a value is 5, so it's going to be 5 squared, plus the b value is 12. It's going to be 12 squared equals c squared. And then 5 times 5 is 25. 12 times 12 is 144. So we get 169 is equal to c squared. And the inverse operation of squaring something is to take the square root. And so if we take the square root of both sides, I could use a calculator to do it, but I know that the square root of 169 is 13. So the hypotenuse of that triangle number 2, the length of it is 13. Number 3, this is going to be our c value. It's the hypotenuse. It's the side opposite the 90-degree angle. We're going to have a squared plus b squared is equal to c squared. We'll call this our a side and this our b side. Again, the order there doesn't matter. So 12 squared plus 9 squared equals c squared. 12 squared is 144. 9 squared is 81. And that gives us 225 is equal to c squared. And that's going to give us the square root of both of those. Square root of 225 is 15. I'm going to check that square root of 169 really quick. It is 13. Very good. Okay, continuing, we have the hypotenuse identified right here as c. We'll call that a, we'll call that b. We've got a squared plus b squared equals c squared for the Pythagorean theorem. So 16 squared plus 12 squared equals c squared. I don't know what 16 times 16 is. We're going to check. $256 plus 144 equals c squared. I think that that's going to give us 400 equals c squared. I'm just going to double check. And it does. So the inverse operation of squaring something is to take the square root. So square root on the right, square root on the left. Square root of 400 is 20. So 20 would be the length of the hypotenuse of that triangle. Got a couple more pages of these to go here. And some additional practice in there. So I'm actually going to split this into 2 separate videos. But we've got, in the case of this one here, we have our value c right there. And we're going to have a squared plus b squared equals c squared. We can call 12a, we'll call the 15b. So 12 squared plus 15 squared equals c squared. That's 144 plus 225 equals c squared, which is going to give us 369 for c squared. And I think the square root of 369, I don't know what it is actually. 316, I think it's going to come out. Let's do the addition piece really quick to make sure I did that correctly. So 144 plus 225 is 369. So square root of 369. We're just going to go to the nearest hundredth. It's going to be 19.21. So the hypotenuse there would be 19.21 units long. Here we have c. Call this a, call this b. A squared plus b squared equals c squared. And so we have a is 9. b is 12. We get c squared there. And so we have 9 times 9 is 81. 12 times 12 is 144. That gives us 225. Square root on both sides. Square root of 225 is 15. So 15 equals C. All right, number 7, we have again a squared plus b squared equals c squared. This was be our a, this will be our b. Our c is always the hypotenuse. So we have 18 squared plus 24 squared equals c squared. 18 squared is 324. 24 squared is 576. So 324 plus 576 is going to give us 900. And I know that the square root of 900 is 30, so I don't need to use my calculator for that. 30 is equal to C. Number 8, we identify our C. We'll call this our A, we'll call this our B. A squared plus B squared equals C squared. We have 16 to the power of 2 plus 12 to the power of 2 is equal to C squared. And so 16 times 16 is going to be 256 plus 144 equals C squared. That is going to be 400 equals C squared. I feel like we had that one already. Square root of 400 is going to be 20. So the hypotenuse there would be 20. The last two for this page, we will call this our A side, we'll call this our B side. This has to be our C for it because it's the hypotenuse. We might as well label this one over here as well. A squared plus B squared equals C squared. The A is 100, the B is 200, and the C we don't know. So 100 squared is going to be 10,000. 200 squared is going to be 40,000. I think. I'm just going to double check that. And so 10,000 plus 40,000 is going to be 50,000. The inverse operation of squaring something is to take the square root. So we're going to take the square root of 50,000. We get 2 to the nearest hundredth is what we're going to round to, so we get 223.61. All right, so A squared is 36. The A is 36 squared. The B is 27 squared equals C squared. 36 times 36 is 1296. 27 times 27, 729. And so 1296 plus 729 is 2025. Take the square root on both sides. square root of 2, 0, 2, 5 is 45. So the hypotenuse length of that triangle would be 45. So this is a nice part for a break. We're going to stop right there, and I'm going to make a separate video for this next piece.